Okay, special daytime advent of code, day 15. Last night was my office holiday party, so I was not anywhere near the computer at 9 p.m. or even at 10 p.m. And so it's good. It means I get to drink. Well, one, it means I can't get on the leaderboard, but two, it means I get to drink coffee while I'm doing it, which is nice. But also, I'm not feeling that great, so hopefully that does not impact me. I don't think it will. Why did it say not streaming? Let me reload this. Maybe it's just live streaming. I don't understand what's going on here. There's like it's doing a bad thing where I'm logged in as me, and I'm also logged in as my my work account, and it's causing me a lot of problems. So I apologize for this. And let's go to Creator Studio Classic. Something is missing. Live streaming tab. Okay, now I'm logged in as me, and now if I go to live streaming, it still says I'm live. Okay, so I'm going to because I just wasted a bunch of time figuring this out. I'm going to stop this and restart it so that when I do the video to post it, I post it online. It will be fine. I don't have to include this stupid part, so I'm going to stop it and then I'll restart it really quickly. So. Okay, so once again, this is a special day 15 during the day edition because last night I was at a holiday party and so I didn't get a chance to do this last night, and I'm not feeling that great today, so hopefully that doesn't affect anything. I don't think it will, but I think we're in good shape. So let's go find the problem, and hopefully it works out for us. So day 15. Beverage bandits. Having perfected their hot chocolate, the elves have a new problem. The goblins that live in these caves will do anything to steal it. Looks like they're here for a fight. Scan the area, generate a map of the walls, open caverns, try and position a goblin and elf. Combat proceeds in rounds. Each round, each unit that's still alive takes a turn, resolving all of its actions before the next unit's turn begins. On each unit's turn, it tries to move in range of an enemy and then attack. All units are very disciplined and follow very strict combat rules. Units never move diagonally. That would be dishonorable, and multiple choices are equally valid. Ties are broken in reading order, top to bottom, then left to right. For instance, the order in which unit takes their turns is the reading order of their starting position in the round, regardless of unit or other units, for example. Okay. The unit begins its turns by identifying all possible targets. If no targets remain, combat ends. Then the unit identifies all the open squares that are in range of each target. Squares which are adjacent to any target are already occupied. Alternatively, the unit might already be in range of a target. If the unit is not already in range of a target and there are no open squares which are in range of a target, it uses its turn. If it's already in range of a target, it does not move, but it attacks. Otherwise, since it is not in range of a target, the unit is not already in range of a target, and there are no open squares which are in range of a target, the unit ends its turn. To move, the unit first considers the squares that are in range and determines which of the squares can reach in the fewest steps. Step is a single movement. Units cannot move into walls. The unit does this while considering the current positions of units and does not do any prediction about where units will be later. If the unit cannot reach any of the squares that are in range, it ends its turn. If multiple squares are in range and tied for being reachable in the fewest steps, the square which is first in reading order is chosen. For example, targets in range reachable nearest chosen. In the above scenario, the elf has 3 targets, the 3 goblins. Each of the goblins has open adjacent squares that are in range. Of those squares, 4 are reachable. The other 2 would require moving through a wall or unit to reach. 3 of those reachable squares are nearest, requiring the fewest steps to reach. Of those, the square is first reading order. The unit then takes a single step towards the chosen. This is like a book. Single step towards the square on a short path square. Multiple steps will put the unit equally closer to its destination. Unit chooses the step which is first in reading order. This requires knowing when there is more than one shortest path, so you can consider the first step of each such path. For example, in range, nearest, chosen, distance, in range, nearest, chosen, distance, step. As the step which is first in reading order is chosen, the elf moves right 1 square. Here's a larger example of movement. Initially, after 1 round, after 2 rounds, after 3 rounds. Once the goblin's elf positions above, they're all either in range of a target or cannot find any square in range of a target, and so none of the units can move until a unit dies. After moving, or if the unit began its turn in range of a target unit attacks, so attacking it first determines all the targets are ranged by adjacent to it, knows the target begins its turn. Otherwise, fewest hit points is selected, and a tie the adjacent target with the fewest hit points first in reading order is selected. The unit deals damage to its attack power using its hit points. This reaches input 0, dark, blah, blah. Each unit, either goblin or elf, has 3 attack power and starts with 200 hit points. What is going on here? For example, suppose the only elf is about to attack. Each point column shows the golem to the left, blah, 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 blah. Elf in range of 3 targets. Because 3 targets in range, the ones with the lowest hit points are selected. The 2 of these are selected. The selected goblin's hit points are reduced by the elves. After attacking, the unit turn ends. Regardless of how the unit turn ends, the next unit in the round takes its turn. If all units have taken turns in this round, the round ends and a new round begins. The elves look quite outnumbered. You need to determine the outcome of the battle. The number of full rounds that were completed, not counting the round in which combat end, multiplied by the sum of the hit points of all remaining units. But it only ends when a unit finds no targets during its turn. So below is the entire sample combat. So we have hit points after 1 round. Goblin moves there, does nothing. These guys both attack each other. This goblin does nothing. This goblin gets attacked by the elf. This elf gets attacked by the goblin. Move. Eventually, top elf dies after 47 rounds. Before the 48th round can finish, top left guardian funds. So 4 rounds were completed was 47. And the sum of the hit points of all remaining units is 590. From this, what is the outcome of the combat described in your puzzle? This is freaking. Anyway. All right. 8 people watching. Wow. Okay, so this is involved. So let us just get to it. Day 15, beverage bandits.py, and let us give us some thought about how we want to model this, and let's copy this sample combat and just delete these parts of it that are not part of the combat. Okay, good. So that's a sample combat. And let's think about how we want to model this. So we have either an elf or a goblin, and each has a hit point and an attack power. And each unit has 3 attack power and starts with 200 hit points. Let's say class, what are we calling these guys? Elf, semi problem, goblin. Fighter. And a fighter, and let's say elf, a boolean, and we said it has attack, which is 3. Attack is an int equals 3, and HP is an int equals 200. And so self.elf equals elf, self.attack equals attack, self.hp equals HP. And now let's say is I'll leave it like this for now. And once again, I need to decide how I want to represent this board. And now, because it's a grid where everything is full, I'm just going to represent the board as a list of actually, you know what? I'm just going to represent the wall. I'm not going to represent the board because I don't need to do the open space. I'm just going to represent the walls and the characters. So again, I'm going to parse some raw, which is a string, and it is going to return me from typing import set and list and tuple, and it's going to return me a tuple containing, let's say, a set of, and I'm going to do the same thing I did here and possibly regret it, is say a pos, same thing I did a couple days ago, name tuple, which is going to be x and int and y and int, so that's fine. So it's going to return some positions, which are going to be the location of the walls, and then it's also going to return a list of fighters. And so I think that's right. And so what I want to do is I want to say for, and again, we'll call this I'm actually just going to call it the way I would like to call it. So for I row and raw dot split on new lines, and then for j c in, and I should have done enumerate, in enumerate row dot strip, and I'm probably going to regret this. No, I don't think strip will matter now because I've got the thing. So I say if C equals, and let's say walls equals set, and fighters equals a list. And so I won't forget now, I'll say return walls fighters. Okay, so if it's this thing, which I think is a wall, walls dot add position ij. So let me change this to I and j this time. Otherwise, if C equals, and it says E, yeah. Fighters dot append fighter elf equals true, and then I can use the default for the other ones. And then if C is a goblin, fighters dot append fighter elf equals false, and then that should be it. So let us try running this. Run day 15 beverage bandits.py, and let's say parse of raw. That gives me a bunch of walls, and unfortunately my fighters aren't very well represented. So let's say self goes to string, and let's say return fighter elf equals self.elf, attack equals self.attack, and I need to take a position pause, which is a pause, self.pause equals pause, attack equals self.attack, HP equals self.HP, and let me do pause equals self.pause. So let me run it again. Init missing because I didn't do fighter elf equals pause equals pause ij, and again pause equals pause ij. So wasting a lot of time just doing the modeling. So fighter elf equals false at I equals 1, j equals 2. That's fine. Elf equals true, I equals 1, j equals 4. That's fine too. Okay, good. So I think I believe this. So now let us do the following. Combat proceeds in one round. In each round, each unit that's still alive takes a turn, resolving all of its actions before the next unit's turn begins. And goblins live in these caves. So I'm going to go back and do the following and say a cave is a named tuple, and it's going to have walls, which is a set of positions, and then fighters, which is a list of fighters. And then I'm going to change this to return a cave, and I'll just do cave of walls and fighters. So I think this will make our lives a little bit easier in that each round, each unit is still alive takes a turn. Okay, so we need to say take turn self, and we'll have to know about the cave that it's in. And once it takes a turn, what is it going to do? I'm not sure what I'm going to return, so I'm going to say none, but we're going to worry about that in a bit. We're probably going to want to return something. Let's return a bool and say that returns whether it was able to do something. Returns whether it was able to do something, because we can use that as part of our stopping condition. So I want to take a turn. And so when I take a turn, I want to say so let us start giving cave some methods. I'm going to want to give cave some methods too. So let's just write out the steps that it tells us to take, and then we can figure out how to do them. Okay. First, consider the squares in range, and considers the square. So if in range, attack. So if in range, attack. Otherwise, or actually, let's say if no enemies, return false. If enemy in range, attack. Is that right? It's an attack. Otherwise, else move and then else move and maybe attack. So I think that's right. Okay, so let's just figure this out. Let's say enemy locations equals fighter.pause for fighter in cave.fighters if fighter.elf not equal to self.elf. So if it's a different person than me, then So if I'm an elf and that's a goblin, or I'm a goblin and that's an elf, then that's my enemy. So here's my enemy locations. And so if not enemy locations, so if that list is empty, so there's no people at all, I want to return false. No enemies found. So that's kind of our stopping condition. Okay. Otherwise, if enemy and range attack, so let's look at neighbors, which is self and goes to an iterator of pause. So every time iterator. So as I remember it, if multiple squares are in range and tied for each square, it's just first in reading order. So reading order is always so it does not move, so to move, blah, blah, blah. It takes a single step on the shortest path of the square, so these 3 squares. And to attack, all the targets in a range being immediately adjacent. Otherwise, the adjacent target with the fewest hit points is selected. Okay. In a tie, the adjacent target with the fewest hit points, which is first in reading order. So let me do, let me think about this. Otherwise, if enemy arrange attack. So let me just go back to what I was doing because I think I need to do that. Pause. Return. Let's just say yield pause. I minus 1 j. I'll just do this. Yield from. And do I care about the order? I might. I plus 1 j pause I j minus 1 pause I j plus 1. Okay, so those are my neighbors. And let's say enemy actually, so I don't want to do fighter.pause. I want to do just enemies equals fighter for fighter and cave.fighters. If fighter.elf is not equal to that, if not, enemies return false. So now let's say adjacent, and let me do this. Fighter.pause. So this is going to be a dictionary where the key is the position, and adjacent enemies equals so what do I want to do? I want to say enemy for, no, let me just go back and do that. This should be fine. Adjacent enemies equals enemy for enemy. So rather than this neighbors, I'll leave it there. But what I want is adjacent self other, which is a pause, and that's going to return a bool. Return either self.I abs self.I minus other.I equals 1, and self.j equals other.j. So it can be either this or, so i's differ by 1 and j's are the same, or abs self.j minus other.j equals 1, and self.i equals other.i. So that means they're adjacent. I should be writing tests for all this stuff, but there's a lot of stuff to write tests for. enemy for enemy and enemies. If self.pos dot adjacent enemy.pos. Okay. And now I want to, if adjacent enemies, I want to do the following. And let me just self.dead equals false. I think I might need to use that. If adjacent enemies, choose the one with the lowest hit points and then reading order. So let me define a little function that says so I minus one, so let me call this reading order. I need to think about what the smartest way to figure out reading order is. Actually, I don't even need to do this yet. Let's say adjacent enemies dot sort key equals enemy sort key equals self dot enemy. Does that work? I think that works. So def enemy sort self enemies, which is a list of fighter, and it is going to I'm not going to punt on what it returns. And so what I want to do is I want to say it's not enemies, it's going to be enemy, which is a fighter. And so first I want to sort by hit points. And then let's say if adjacent, no, if self.pos dot adjacent enemy pos. Actually, let me do the following. Okay, so this is going to return a number indicating the reading order. Lower is earlier. Minus one is not adjacent. So this is like a bad hack, but you know, if so ij equals self.pos. So here's what I'm gonna do. I1 equals self.pos dot I no equals self.I. No. Okay, so if self dot, so first is self dot j equals other dot j and self dot I minus 1 equals, oh, this is not good. It's a real pain in the ass. Yeah, it seems long. All right, so let's go back to where I was. So I have these. So I want to sort these by sort and equals lambda enemy, and I want to return two things. One, enemy.hp, and two, so how many hit points does the enemy have? So that's going to be the lowest. And then I also want to know, sort by the direction from self.pos to enemy.pos. And so that's only going to bite if, so I need to define what this direction function is. So def direction from pos is a pos, and to pos is a pos, and it's going to return an int. And let's say that if not from pos dot adjacent to pos will return -1. Otherwise, they're adjacent. So let's say I1 equals from pos dot I. Let's say I1 J1 equals from pos dot I to pos dot from pos dot J. I2 J2 equals to pos dot I to pos dot J. And now what I want to say is that if we're going up, so J1 equals J2 and I don't need parentheses here. J1 equals J2 and I1 is bigger than I2, so that means you're going up. Return 0. Otherwise, and the next one is to the left, so that's saying I1 equals I2 and J2 is less than J1. So I'm going to rewrite this as I2 is less than I1. So then we'll return 1, and then next will be to the right. So if I1 equals I2 and J1 is less than J2, then I want to return 2, and then otherwise I'll return 3. So that should give me the right order. And now I have adjacent enemies sort, so that's fine. And now if adjacent enemy, so if that's not let's say attack and then return true. So how do I attack? I will say attackee equals adjacent enemies 0. Attackee.hp minus equals self.attack. And then I think we said if hit points to 0, if attackee.hp less than or equal to 0, attackee.dead equals true. And then we'll return true because we were able to do a move, able to do something. And then otherwise, we need to move and maybe attack. So, and so we're going to need to do this this logic again. I'll probably copy and paste it because I'm a bad person. So let's go back and figure out how we move. To move, The unit first considers the squares that are in range. And so what does in range mean? Squares that are in range determines which of those squares it could reach in the fewest steps. A step is a single movement to any adjacent units cannot move into walls or other units. The unit does this while considering the current positions of units and does not do any prediction about where units will be later. If the unit cannot find an open path to any of the squares that are in range, it ends its turn. If multiple squares are in range and tied for being reachable, the square which is first in reading order is chosen. Okay, so I think that's good. In fact, this direction thing was, so basically, I didn't even need to do this, I don't think. All I want to do do reading direction is I just want to sort by enemy.hp, and then if there's a tie, I want to do enemy.I, which is the highest row, and then enemy.j. So once I do that, that should give me for free lowest HP, then lowest row, then lowest column, which does exactly what I want. So I don't need any of this stuff, so let's just delete it because it's not useful. And I'll need it later, and then I'll regret having deleted it, but that's fine. So Elf has 3 targets. Each of the goblins has open adjacent squares which are in range. Of those squares, 4 are reachable. The other 2, 3 of the reachable squares are nearest. Of those, the square that is first in reading order is chosen. Okay, so squares that are in range determines which of those squares it could reach in the fewest steps. Okay, so let's say, what do we call those? Squares that are in range. So in you know, let's say could move to equals cave dot in range of self. So I'm going to give the cave a function that says, this is going to be where the bulk of the work is, so you know, def in range self, and it is going to take a fighter, which is a fighter, and it is going to return a list of positions where this person might want to move to. But in fact, squares which are in range from which the squares reach in the fewest steps, blah, blah. So rather than doing that, I'm just going to say move target equals cave dot move target self. So I'm just going to def move target self fighter, which is a fighter, and this will return an optional pause. So let me import optional. You know, this will return the square to move to. Or none if no such square. Okay, so unit squares are which of these squares it could reach in the fewest steps. Unit does this while considering the current positions of units and does not do any prediction about where units will be later. If the unit cannot reach any of the squares that are in range, it ends its turn. If multiple squares are in range and tied for being reachable in the fewest steps, the square which is first in reading order is chosen. Okay, so this is going to require us to do a breadth first search or something, so we might as well import our queue. From collections, import double-ended queue. And let's see if I can figure this out. So, say enemies equals, what did I do? Adjacent enemies. So let me say, and not enemy.dead. So let's do that. And I'm going to put this everywhere too. So enemies equals, oh, actually, let me put that up here. And so again, here's my enemies. And let's say off limits equals self.walls plus f.pause for f in fighters, if not fighter.dead. So these are places I can't move. I can't move anywhere there's a wall, and I can't move anywhere where there's somebody that's not dead. So let's keep that in mind. And so I want to keep track of my paths. So let's say Q equals a deck of a path that just has fighter.pos. Okay. And what I want to do is say while Q, and did I have these neighbors? Good, I do have these neighbors. That will be the following. So I basically want to find and let's say valid paths equals this. So while Q, let's say path equals Q dot pop left. God, this fucking F key doesn't work. So I'm going to pop off the left-hand side of the queue. Okay. So now I have a path. And let's say pause equals path -1. So that's the last place I was. And now let me do the following. For pause 2 and pause dot neighbors. Okay, so for each of his neighbors, if pause 2 in off limits, so if that place is off limits, I'll continue. And if pause 2 is in the path, so I don't want to repeat myself, right? So then I'll also continue. And then so let me do the following. If any pause dot adjacent enemy dot pause for enemy in enemies. Let's say valid paths dot append path. So this path, so I pop off a path. If it's next to that guy, that's good. If it's off limits, don't do it. If it's repeating itself, don't do it. Otherwise, q dot append, and I might need to prune these out a little bit better, but I'm not going to worry about that for now. Otherwise, q dot append path plus pos2. And now the worry is that we can find multiple shortest paths. And so the way breadth first search works is that it's going to explore like all paths at distance 2, all paths at distance 3, all paths at distance 4. So like it might find multiple paths at distance 4, but once it finds a path at distance 5, it's never going to find a shortest path, right? And so as I understand it, I want to find which is reachable in the fewest steps. So what I'm going to do is the following. Shortest is none. Okay. So if any, so that's good. If so let me do the following. If we're too long, break out of the while loop. So if shortest and shortest is less than the length of the path, then break. Okay, so now this is saying if we're next to an enemy, valid paths append path, and now we can say shortest equals len path, because if the length of the path was bigger, we would have broken out. So now we can definitely set it. And now we just do this. So q, so at this point, shortest paths has all the shortest paths. If multiple squares are in range and tied for being reachable in the fewest steps, the square which is first in reading order is chosen. Okay, single step along the shortest path. If multiple steps would put the unit equally closer to its destination, the unit chooses the step which is the first in reading order. This requires knowing when there is more than one shortest path, so you can consider the first step of each shortest path. So need to sort by one reading order of destination, 2 reading order of first step. Okay, so shortest paths dot sort key equals lambda path. So the reading order destination is I of destination and then j of destination. So that's path minus 1 dot I, path minus 1 dot j, and then I also want to do the reading order of the first step. So that's path path minus 1 is the starting point, so I actually don't want that. I want path 1 dot I, path 1 dot j. Okay, and so, and then next pause equals shortest paths, or actually, so if shortest paths, so if we have shortest paths, next path is shortest path 0. Shortest path 0 is the first one in the sort order, and then 1 is the next step. Dot pause, and then I want to move to that position. So let's say fighter dot pause equal. Oh, I'm just going to return it because that's what I said I was going to do. So I'm going to return it, and then otherwise I'm going to return none. So let me say cave equals parse raw. So let me run this. Expected and indented block line 39. We haven't run this in a long time. Don't need that. Run that. Cave is not defined. That is true. So let us do that. Okay, and cave is this. And now what I want to say is so which one did I use? I used this example, and so cave dot fighters 0, cave dot fighters 0 is the elf at is the goblin at 1 2, and so he is going to want to move 1 to the right. So the one that's more interesting is the one at -2. Cave fighters -2 is the goblin at 4 3. And now I want to figure out where does he want to move. So I figure out where he wants to move by saying cave.move target. So let's say goblin is that guy, and let's say cave.move target of goblin. Cave is not defined. Name error cave is not defined because this is the cave. So this is self.fighters. I should not have picked a name with an F on it, given that the key on my keyboard is not working well. So do that, and let's say goblin is this guy, and then cave.move target goblin. Cave has no attribute elf. If enemies equals I shouldn't I reused the same name twice. That's bad. F for F in self.fighters. If fighter.elf is not equal to F.elf and not F.dead. F.pause from fighters if not F.dead. And I think you don't add, do you add sets like that? X equals 1, 2, plus 3, 4. Yeah, I think you have to use and. No, not and. You have to use or. Yeah. Okay, so or. So let's try this one more time. Goblin. Name fighters is not defined. And F in self.fighters. And let me just stick my other thing in here so that I don't have to keep typing it. Int object has no attribute adjacent. If any, pause dots. So what's pause here in line 86? So let's just print path and see what happens there. Path how is that possible? Print Q is a deck consisting of that position um, because it needs to be a path like this. So that's the problem. So I'm starting with a path. Name I is not defined because I didn't use self. IJ equals self.I, self.j. So lots of bugs here, huh? Funny what happens when you write this much code. Name shortest paths is not defined. So valid paths. Valid paths sort. If valid paths. Okay, so let's try again. Name shortest paths is not defined. Let's try it again. Pos has no, okay, because it just is the position. So we're saying that this guy moves to 1, 2, 3. So that's right. And then what about, say, cave.fighters 0. That guy says he moves to I equals 1, j equals 3. That's right. And just for fun, let's see what happens if I do it on fighters 1, who's not supposed to move. It'll probably complain list index out of range. So that's fine because he doesn't need to. I don't think he needs to do that. So it seems like it works. And now, again, I've all right. So I've totally I've lost the train of thought. So now, what do I need to do to so take turn? So if move target is none, so that says there's nowhere to move. If there are no targets, the unit ends its turn. And so he's going to return false because he wasn't able to do anything. And then otherwise, and I am inside the fighter now. So I'm going to say, I'm going to change my position to move target. So I'm going to move, and then maybe attack. So for now I'm just going to copy this code, which I don't feel good about, and actually, you know what I can do is I'm just going to copy it. And I feel very bad about copying this, but so adjacent. So otherwise, I move. So changing my position, I find the new adjacent enemies, and if they're there, I'm going to return true because I moved whether I attacked or not. So I think that is take turn. And so now what I want is the cave to do a round. So round self, and it is going to I don't know what I did here. Okay, return true if anything. Return true if the game is not over. So, so what I want to do is strict combat rules. Ties are broken in reading order. Top to bottom, left to right. Open squares. Blah 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 blah. Okay, so the order in which units take their turn within a round is the reading order of the starting positions in that round. Regardless, so let us, so one is self.fighters dot sort key equals lambda f f dot pause dot I f dot pause dot j. So I think repeatedly we've said that is how we want to do it. So we'll go row by row and then column by column with that. And now for fighter in self.fighters, if fighter.dead, continue. So we don't want to do anything with a dead fighter, obviously. And if he's not dead, then let's say did move equals fighter dot take turn self, which is the cave. And let's say game over equals true. If did move game over equals false, and return game over. Okay, so this is my cave, and now I want to say, and what do I want to return? I want to return hit points of all remaining units at the moment combat ends. So what is okay? If all units have taken turns in this round, they're on ends. Else, I don't know. So let me make sure I understand how this ends. Before the 48th round can finish, the top left goblin finds that there are no targets remaining, and so combat ends. So what happens if there's no move? That's what I'm worried about. Like, there's enemies remaining, but unit identifies all open squares that are adjacent. If there are no open squares which are in range of a target, the unit ends its turn. So that's fine. It ends its turn. And combat ends only when a unit finds no targets during its turn. Okay, so I think I got some of this logic wrong. And that's the following. When I take a turn, if no enemies, I returns whether it found enemies. If not enemies, return false. this should return true because it found enemies. That's all we care about. And so now take turn. Game over equals true. So now found so I have this backwards, right? So now what I want to do is found enemies. If not found enemies, game over equals true. So it's a game over equals false. So if the fighter's dead, continue. I take a turn and see if I found any enemies. If I didn't find any enemies, the game is over. And return game over. And then I also want to say sum of all hit points. So let's say total hit points self goes to int. So that's return sum of f.hp for f in self dot fighters, if not f.dead. So it's possible I missed a f.dead somewhere, but so that'll give me total hit points. And so now, after one round, eventually the bottom elf dies before number of full rounds that were completed was 47. So let's say def run game, cave is a cave, and that will return an int. So what do I want to do? I want to say num rounds equals 0. And let's say while true, game over equals cave dot round. If game over break, otherwise num rounds plus equals 1. Okay, so if there's nothing to do at the following, I think we get 0 rounds. And then what do I want to return? I want to return num rounds times cave dot total hit points. Okay, so let's see what happens if I do this. Run game cave. Name enemy is not defined. So let's go to line 41 and turns whether it founds enemies if and not fighter.dead. So that means since I copy and pasted, I probably no, I didn't. Okay, so let me just stick it here. Run game cave, and I'll actually move this down here and just see what happens. Oops. Fighter object has no attribute I. That's true. Enemy.pause. And it's possible that I could have just done enemy.pause because it has I and J in that order. In fact, I'm sure I could have done that, but I didn't. 49. That's where the copy and pasting gets me. And why did it not return anything? So let's try this again. Cave, run game, cave, 27,730. So holy shit, look at that, 27,730. Okay, you gotta admit you're pretty freaking impressed. I got that right, aren't you? Assert run cave equals 27,730. That is pretty damn good. Um, I'm I'm as shocked as you are that that's right. So now, um, let me just do a few more of these. Cave2 equals parse of, and God, I wish they wouldn't do this to me. Um, um, assert run game cave2 equals 36334. Okay. Should I do one more of these or should I just run it? I'll do one more. I'll do this one. 18740. Cave3 equals parse. And again, I hope part 2 is not as long as part 1. Assert run game of cave3 equals and 18740, let's say. Okay, well that's not good. So that tells me that I have, looks like an infinite loop somewhere. So we should probably check that. So let's say cave3 dot fighters, and I should probably, well, I have their hit points, so that's fine. Let's say cave3 dot walls. And let me do a repr on this too, which will make our lives easier. Okay, so again, let's say outputs equals pos for pos and self dot walls, fighters equals pos dot, and let's say if f dot elf else g for f in self dot fighters, and let's say min and keys equals outputs dot keys plus list outputs dot keys plus list of fighters dot keys. Min I equals min of pos dot I for pos and keys. Max I equals max of pos dot I for pos and keys. Min j equals, actually, we know it's going to be 0 for all of them. So I'll just do max I and max j, max pos dot j for pos and keys. And then what I want to do is I want to say return new line dot join of and so let me do the following. Outputs equals this, comma, and this is like a magic dictionary unpacking thing. So that'll make our lives easier, actually. So I've just taken these two dictionaries and combined them. And now I can just do for pause in outputs, and for outputs in.join blank.join output.get pause ij, and then by default we'll do a period for j in range max j plus 1, for I in range max I plus 1. So I think that's right. So let me run this and say cave 3, name pause is not defined, equals f.pause. Okay, so I have this thing, and so that looks right. Why is it not cave 3.fighters1 is an elf with 200 hit points? So there's some kind of logic error here. And that's, let's see, cave 3 dot round. So why did that cave 3 dot fighters1? So how did he get so low? So let me do a couple things. Let me print round num rounds. So that's good. And now if I'm attacking, adjacent enemies, print f self attacks attackee, and let me do this too. And print self moves to move targets. Okay, so let me do this with a little bit of extra debugging and see what happens. Why is this guy, I equals 2, j equals 1, not losing any hit points? He's not losing any hit points because other people are attacking each other. So that's probably fine. So this is working, it's just taking a long time. So the question is, why is it taking so long? So let's figure this out. And so we'll print the cave itself. And now, instead of saying who's attacking whom, because you know the slow part is the breadth first search. So let's just print that, and so move target. So let's print fighter considering where to move to. And then print chose next pause. prints nowhere good to go. So let us run this. And it's the second guy here. Fighter elf equals false, pause equals I equals 5, j equals 2, considering where to move to, and there's nowhere good to go, which is true, because there's no path to get him there. So we can add so I'm trying to think if I want to add a hack, and the hack is it's expensive to do this search every time, but if all the positions that are occupied are still occupied, so what I want to say is the following. So when I run a cave for the round, let's say the following. Self.occupied equals f.pause to f.elf for f in fighters. And then at the end, let's say self.last occupied equals occupied. And so when I and to start with, I'm just going to say say occupied equals none. So what I want to do is basically when I do this round, and so what I want to do is I want to say occupied equals this, and then no movement last round equals occupied equals last occupied. So if there was no movement last round, and take turn self and actually let me do it this way. Movement last round is occupied not equal to. So I'm going to track if there was movement last round. Because if there was no movement last round and I didn't move last round, then there's still nowhere for me to and so this should be if not f dead. Okay, so I go to fighter take turn because I'm sure they're gonna like do this to me in my problem too, in the big one. Okay, and so self dot moved last time equals false. So I'll do this too. And now when I do take turn, and what was that extra one? I called it movement last rounds. Movement last round is a bool. So otherwise, so if movement last round or self dot moved last time, then I will do this, and okay, this logic is getting kind of complicated. Move. So actually, let me change this. If not moved last time and not so if I didn't move last time and there's not movement last round, then I'm just going to return. Just return. If I couldn't move last time, I can't move now. And self dot. And now I need to update this. Self moved last. Self dot moved last time equals false. Self dot moved last time equals true. And what I'm going to do is I'm going to say if I attacked somebody, I'm going to say self dot moved last time equals true too, so that I don't want to count myself as being stuck. Okay, so now if I run this, name error fighters is not defined. That's fine. I've kind of made a slight mess of this, so if I broke it, occupied not equal to self dot last occupied. Cave object has no attribute last occupied. Cave object last occupied is read only because this is a named tuple and I can't. Okay, so I'm going to do something very bad. Is that I'm going to make it a list and then I can modify it. That's it's a very bad thing to do, but I'm going to do it anyway. It's easier than the other thing. Okay, so this considering where to move to is still slow. So whatever I did, I didn't get it right. But let me put these asserts back in and make sure I didn't break anything. Okay, so these I don't think seem to have broken anything. So let's get to considering where to move to. Move targets. Okay, print moved last time. Self dot move last time. Print movement last round. Because one of those is apparently not being set, right? Okay, so it looks like my optimization did work. It just took a while to work because people had to get to their place. So, all right. So let me comment out all my prints and that seems okay. So now let us get this thing. So let's do some data. Day15.text. Put this here. Looks kind of hairy. We'll see if it works. So I'm going to comment this out because so with open data day15.text as f, raw equals f.read, cave equals parse raw, and then I want to print run game of cave. So let's try it. What is this movement moved last round? I don't want that. Move. I thought I commented all of these out, but I did not. So this is kind of cool. We get to watch the game. This round 6 is kind of brutal. And it's chugging along. So this guy's got to figure out where to move. That's easy enough. It's actually these guys who are having the trouble. So while these guys are running, let's think about how do I optimize this. So no one down here needs to move. This guy needs to move. This guy needs to move. And they're slowly moving. This search is really tough. Round 10, 11. I guess as people start dying, there's less guys we got to figure out, but it still takes a long time. Anyway, so what would I do to speed this up? Because I would like to speed it up. So one thing you could do is you could say, here was my target last time. If no enemies have moved, no, actually that doesn't quite work. So like, yeah, see this guy, he's in trouble, right? Because he's got to go all the way around here to find somebody, and that's taking a really long time. So we've only done 14 rounds, right? And if you think about it, each of these attacks, it's going to take 60 rounds to kill one of these guys. So this is going to take forever. So clearly we need to do something better. And that something better is, what is that something better? So let's think about this guy. Like he knows he wants to go to here. Maybe the problem is my unconstrained search is not good. So yeah, this isn't going to work. This is definitely not going to work. Okay, so let us break through this and look at these first few rounds and see what happened. So round 0 is here. Everybody moved. Everybody moved. Everybody moved. Everybody moved. Everybody moved. So we have the basic logic right. The problem is that we're doing something really inefficient, which is I need to figure out where to move to. And Okay, so here's what I want to do. Okay, I have an idea. Is that where is my breadth first search? So what I want to do is I want to say I want to track visited and the shortest path to get there. So that way, if I visited somewhere in 5 steps and I'm looking at 10-step paths, I don't even want to consider it, right? So visited equals fighter.pause 0. Okay? And so I'm looking at these neighbors. If pause 2 in visited and visited pause 2 is less than or equal to what is this shortest here? Is less than len path, then continue. So I'll say was already a shorter way to get here. Okay, and then finally I want to say otherwise visited pause 2 equals len path plus 1. So we did not know a shorter way to get there, so this must be the shortest way to get there. So now let me try running this again. So we got to around 14 faster, but we're still having challenges. And so the challenge is so I'm going to print path and print visited. So this is going to print way too much stuff, but we'll run it and see what happens. Yeah, that's not helpful at all. Okay, so forget visit. I'm just going to print the. I'm going to print fighter.pause and path. So I'm going to run that. And let me change this and just print. Let me just do this, just so I can keep track of who's doing what. Okay, so this is where I got stuck, and this is the goblin and line 0, 1, 2, 3, 4, 5, 6, 7, and 20, so he must be the first one. So he does have a long way to go. The question is, let me see how, print max visited values. This is going to be way too much, but Okay, so I think I know what the problem is. The problem is that I need to, um, I'm tracking multiple paths to the same place, and I don't want to do that. So what I want to do is, I think what I want to do is the following. Um, uh, so let me change this rather than visited. Let's say best path equals um, fighter.pause to, and it's just going to be the path that only has him. Okay. Um, and uh, so if we're too long, break out of the while loop. That's fine. If we're next to an enemy, um, so this is not what I want to do. Um, actually, that's probably okay. So now I want to do the following. Uh, so, so if pos2 in best path, so we already know a path here. New path equals so let me think about this for a second because I'm getting confused. I know how to get here. If I find another path to get there, then I only want to keep the better one, but I might already have it on the queue, so I need to kind of get it out of the queue. So now, all right, so I need to rethink this a little bit. So okay, so I'm going to need to rewrite all this, which is bad. So the best path is fighter.pause and that's fine. Fighter.pause. So the best way to get to where I started, and now Q equals a double-ended Q of fighter.pause. Okay. And so now what I want to do is I want to say, rather than maintaining a path, I just want to pop off. So while true, say pos equals q dot pop left, and so shortest to here equals len of best path pause. Shortest to here. And so let me copy this. Closest enemy equals, no, this is not working. Maybe I can't do a star search off the top of my head. Let me look at Wikipedia. Three multiple points. Pre-processors. The challenge with doing a star is that it's going to an estimate of the cost required to extend the path all the way to the goal. Selects the path which minimizes that. I don't. The complication is this idea that at every step we need to prefer the one that or of the targets we prefer I feel like that's not the challenge. The challenge is that we have to incorporate this like reading order thing somehow, and now I've actually almost forgotten what is being asked here. So like basically when I'm searching, I have two things. One is that if there are ones that are equally close, I need to prefer one of them. And then if there are multiple paths to get there, I need to prefer one of those two. And so what I feel like I want to do is I want to okay, well I've lost my thing, is that basically you know, I look at here's all the places I can get to, and maybe that's the answer. The answer is that I say what's the best place to get to, and now what's the shortest path to get to that place, right? And then it sort of becomes a star search, except again, I still have to prefer the going right to the going down. And so that, but I guess that just means that going right has a slightly smaller cost, right? So I do this by basically, okay, right. So let me, so I think this is totally wrong. Totally wrong. So let's just say targets equals pause for enemy in enemies for pause and enemy dot pause dot neighbors if pos not in off limits. So these are the places I would like to get to. These are the places I would like to get to. And then I want to sort them. So targets equals sorted targets. Key equals, and I think if I just sort them naturally. And let's just print targets. And so let me rerun this. And new path equals, so I broke some things, which is bad. For pos and enemy.pos.neighbors. Shortest to here equals, so I should be visited is not defined. So like I got to round 6. And now, so I have all these places I want to get to. And actually, I didn't need to sort them because that's not right. So what I want to do is I want to find shortest path to each of the targets. And so that's where a star search seems like it actually does is right. If no fighters died last turn, then there was no movement last turn. Keep moving in the last shortest path. Oh, that's actually all right. So let me find where so movement last round is that I see what you're saying. Yes. So move target should be an optional, rather than returning my next step, it should return the whole path. So return so return valid path 0. That's a smart idea. Move target. And so let's say path to follow equals so let's say self.path to follow is none. Okay, so that's fine. Self.path to follow equals cave. If self.path to follow is none, move last time. Otherwise, self.pause equals, or actually, let me do this. Path to follow equals that. If path to follow is none, otherwise self.pause equals path to follow 0. Self.path to follow equals path to follow 1. Self move last time equals true, maybe attack. And otherwise, if not movement last round and self dot path to follow, then I want to say self dot pause, so just keep going, equals self dot path to follow 0, and self dot path to follow equals self dot path to follow 1. So list index out of range. So that didn't work. That broke things. And that broke things because, why did that break things? Because this is the fighter who is at 1, 4. His valid path is the one that goes here. And so because did I what is path? Did I remove the guy from the thing? No, so I started with him. So so how would I have so let's go here. I have 1, 3, and I want to move somewhere. So why did he not move from round 2 to round 3? He did I equals 1, J equals 4. Yeah, you know what? Shit. I'm gonna go take a break. 2 hours is about my limit on this, and I'm not really getting anywhere. So I'm gonna go off and think about it some more. So I think I'm gonna take a break.